Hello everyone, welcome to School Math Simplified. And today we will complete the last figure it out of chapter 2 Power Play. Let's start with the first question here. That is, find out the units digit in the value of this, right? Okay, for this I just want to tell you one thing. One thing that you need to remember is just figure out the pattern here. 2 raised to 1 is 2. That means unit digit is 2. 2 raised to 2, you have 4. Again, single digit 4, right? 2 cube is 8. Single digit 8. 2 raised to 4 is 16. And last digit, unit digit is 6. 2 raised to 5 is 32. Unit digit is 2. See, it is now repeating. 2 raised to 6 is 64. Last digit 4. 2 raised to 7 is 128, right? And last digit is 8. So can you see the pattern here? 2, 4, 8, 6, 2, 4, 8, and next one 256 will be there and 6 will be there. Okay, so cycle now, right? That means when you have powers of 2, you will have at units place 2, 4, 8, and 6. Hope this is clear to you, right? This thing you need to remember. And one more thing that you need to remember is when the term is divided with when any power divided by 4 and we have zero remainder, zero remainder, right? Then unit digit is last in the cycle. Last in the cycle. And what is the cycle now? This is the cycle. 2, 4, 8. This thing is you are required to remember. Fine. So now let's start with the solution. We have 2 raised to 24 divided by 4 raised to 32. First we'll convert 4 in the powers of 2, right? So this will be 2 raised to 224 divided by 2 square raised to 32. Okay, 4 can be written as 2 square. Fine. Step. Next step is 2 raised to 224 is divided by 2 raised to 64. Why? Because if we have two powers, then they both will be multiplied. Okay, so 64. Now, see, base value is same. You have division here. Then we will subtract the powers. Okay, so 2 raised to 224 minus 64. You will be leaded to 2 raised to 160. Right? Now divide 160 by 4. See, what will be the remainder? The remainder will be 0. Remainder will be 0. And now we will apply this rule. That is, when you have 0 remainder, then the unit digit will be the last in the cycle. That means they are asking for the unit digit of the answer of this, right? So unit digit will be 6. Okay, this is our answer. Just two things you need to remember. Firstly, this cycle. Secondly, this rule. Fine, you will get the answer. Moving to the next question. There are 5 marbles in a container. Every day a new container is brought in, and how many bottles would be there after 40 days? This is simple, right? There are 5 bottles in a container and every day a new container is brought. So total bottles will be After 40 days, okay, total bottles after 40 days be 40 into 5. That means 200 bottles. ये तो बहुत easy था, right? So this is the answer, 200 bottles. I hope this is clear to you. Moving to the next question. Next question is, write the given number as the product of two or more powers in three different ways. The powers can be any integers, okay? To present this in two different ways. Now see, we'll find out the easiest ways now. 64 cube. See, 64, how we can write 64? 64 can be written as 8 into 8. It can be written as 16 into 4. It can be written as 32 into 2. Three ways. Fine. Let's quickly resolve them. The ways will be 8 cube into 8 cube. First way. Second way is 16 cube into 4 cube. Third way is 32 cube into 2 cube. So we have the three ways. Now see how I can split the powers, because this is a rule when you have A cross B cube, it can be written as this also. This is a rule. You had already done that. Part 2, second part, this was the first part. Second part, this is about 192 raised to 8. Right? So 192 raised to 8 can be written as, see, 192 can be written as 96 into 2, first way, right? 64 into 3, right? Lastly, 16 into 12. Fine. You can find another's also, but these are one of them. Fine. So the answer will be 96 raised to 8 into raised to 8. 64 raised to 8 into 3 raised to 8. 16 raised to 8 into 12 raised to 8. Fine. And lastly, we have last part, 32 raised to minus 5. It can be written as, firstly, it can be written as 2 raised to 5 raised to minus 5 is leading to 2 raised to minus 25, right? 2 raised to minus 25. So let's resolve it. It can be written as 1 upon 2 raised to 25, one way. This was the one way, this is the second way, right? Or we can write 8 into 4 raised to minus 5, right? Which is 8 raised to 5 into minus 5 into 4 raised to minus 5. You can directly do like this also. This is the third way. Hope this is clear to you. So moving to the next question. Examine each statement below and find out if it is always true, sometimes true, or never true. Explain your reasoning. The first part of this is cube numbers are also square numbers. So cube numbers are also square numbers. So this answer is sometimes true. Sometimes true. How? Reason is, see, what's the reason behind this? Let's take 64. 64 can be written as 4 cube, right? And 8 square. So cube number is a square number. See, this is true. is mentioning true. But if I take 8, 8 can be written as 2 cube, but it cannot be the square of any number, right? It is not a square. So this makes the result holds sometimes true. So this is clear. This is the example. This is a counter example. CE, counter example. Right? This is failing this statement. So this is clear, right? Now moving to the second part. What is second part saying? They are saying 4 powers are also square numbers. Fourth powers are also square numbers. Yeah, let's see this. So this is true. This holds always. This is always true. How? Reason is, see, what's the reason behind this? Take any power, say a raised to 4. We can write it as a squares a square. Yeah? So any fourth power is in the form of square number. So this is true. This is the result of this. Any power, take any power. 2 raised to 4 can be written as 2 squares a square. So this is the rule, right? So this always holds. Yeah. Part 3. The fifth power of a number is divisible by the cube of that number. The fifth power of a number. See, yes, this is also true. Part 3 is true. The fifth power of any number. So I'm taking the reason. Example will be a raised to 5. When divided with a cube, we get a raised to 2, which means this is wholly divisible, right? Fifth power contains at least 3 powers of the base. Fifth power is containing 3 powers of the base, right? So it is divisible by the cube. So this is holding. Fine. Fourth part. The product of two cube numbers is a cube number. Yes, this is also true. The product of any two cube numbers. So let's take an example of 2 cube and 3 cube, right? And the product will be 2 cross 3 cube, which is 6 cube. Is again a cube number. Yeah, this is also true. Fifth part. Q raised to 46 is both a fourth power and a sixth power. Q is a prime number. See, this never holds. This is never true. 46 not divisible by 4 or 6. Right? 46 is not divisible by fourth power or sixth power. So this never holds. This is the reason. Yeah? Moving to the next question. Next question is simplify and write these in the exponential forms, and you have following parts. And sixth part, we also do this. So you are given with something and you need to find the values of given parts. Let's start with the first part, fifth question. First part. 10 raised to minus 2 into 10 raised to minus 5. Which base is same. They are in multiply. So powers will be added. Okay. Minus 2 plus minus 5. The answer will be 10 raised to minus 7. Solve. Second part. Second part is 5 raised to 7 divided with 5 raised to 4. The bases are same and they are in divide. So the powers will be subtracted. Okay. So 5 cube will be the answer. Third part. 9 raised to minus 7 divided with 9 raised to 4. Base is same, they are in divide, so power will be subtracted. It will be 9 raised to minus 11. Fourth part. 13 raised to minus 2 raised to minus 3. See, 2 powers, so both will be multiplied. Minus 2 into minus 3 is plus 6. So this is the answer, 13. Okay. Fifth part is m raised to 5 and 12 mn raised to 9. See, first we'll solve this product, this brackets of, right? 5 n raised to 12, m raised to 9 and n raised to 9. Now we will rearrange the powers of m and the powers of n. M raised to 5 plus 9 and n raised to 12 plus 9. So it will lead us to m raised to 14 and n raised to 21. This is part 5, question number 5, and all the parts will be simplified to the exponential form. Fine. Now, question number 6. Question number 6 says, you have 12 square is 144, right? You need to find out the value of 1.2 square. Okay? So 1.2 square, it is 1.2 into 1.2. This is simple, will be 1.44. So some students might feel difficulty in solving the decimals. So first convert them into fractions, right? And then multiply numerator and denominators. This will be 144 upon 100, and then convert them into the, it is clear? And similarly with the second part. Second part is 0.12 square. So this will be 0.12 into 0.12. Converting them into fraction, this will be 12 upon 100 into 12 upon 100. So this will lead us to 144 upon 10,000. So the answer will be 0.014 was the third part. Fine. So this was the second part. Now part third. 0.012 square is 0.012 into 0.012, converting them into fraction, 12 upon 1000 into 12 upon 1000. So this will be 144 upon lakh. So the answer will be 0.000144. Fine. The last part is 120 square. That is 120 into 120. This is simple. This is leading us to this answer. Hope this is clear to you. Moving to the next question. Question number 7. Circle the numbers that are the same. You need to find out the same pairs here. For that, you need to solve them individually only. Then you can find out no, if these are same, right? So let's do it. So here 2 raised to 4 into 3 raised to 6 can be written as 2 squares a square and 3 cubes a square. Now see, base value is having same power. So it can be written as 4 into 9 the square, right? You can leave it here. Now look at this. 6 raised to 4 into 3 square. This can be written as 6 squares a square into 3 squares, which is leading us to 36 into 3 the square. Okay, this is 27. Here it is 3 cube, right? So this is 27. 27. So just find out the answer of this. 27 into 4, 108 square, and 36 into 3. This is also 108 the square. So they see we are getting same value, right? 6 raised to 10. 6 raised to 10 is 6 raised to square raised to 5, which is 36 raised to 5. It cannot be equal to them. This is clear, right? 18 square into 6 square. It can be written as 18 into 6 the square, and 18 into 6 is 108 square. See, this is also same to 1 and 2, right? Now 6 raised to 24. 6 raised to 24 will be 6 raised to 2 raised to 12. So this is also not leading us to the conclusion, right? So here we are getting part 1, part 2, part 4. They all are same. Okay, all about this question. Moving to question number 8. Identify the greater number in each of the following. So you need to find out the greater one. First part is 4 cube or 3 raised to 4. You can solve it because this is having less power, so you can solve it. It is like 4 cross 4 cross 4, 84. 3 cross 3 cross 3 cross 3, 81. So which is greater? 3 raised to 4 is greater than 4 raised to cube. So never predict that we have greater value here, so it will always greater, right? Now this is not mandatory that the value which is greater having any power will be greater. Now you need to rectify while solving it. Okay, 2 raised to 8 or 8 square. 2 raised to 8 or 8 square. After solving, you will get to know that 2 raised to 8 is greater than 8 square. Obviously 64. 64 is 2 raised to 6 and 2 raised to 8 is obviously greater, right? Third part, 100 square or 2 raised to 100. So you see, 2 raised to 100 will be approximately 1.27 into 10 raised to power 30. See, now this is 10 raised to 4 only. If I convert 100 into 10 square, then it is 10 raised to 4. And clearly 10 raised to 30 is far greater than 10 raised to 4. So this is leading us 10 raised 2 raised to 100 is greater than 100. Fine. Moving to next question. A dairy plans to produce 8.5 billion packets of milk in a year. 8.5 billion. 8.5 billion packets in a year. They want a unique ID code for each packet. If they choose to use the digits 0 to 9, how many digits should be the code consist of? See here. Is 8.5 into 10 raised to power 9. 8.5 billions means 8.5 into 10 raised to power 9 now. This is one thing. Second thing, they need to use a unique ID with the use of digits 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And for that identifier, each digit having 10 choices, right? Can be choose 10 times. They are having 10 choices. To choose any code, every digit having 10 choices. So the number of digits the code should consist of will be 10 raised to power 10. Why 10 raised to power 10? Because there are 10 digits. These are 10 digits, right? and each digit is having 10 choices. Each digit is having 10 choices. That's why the number of digits the code should consist of is 10 raised to power. Yep. Moving to the next question. 64 is a square number and a cube number also. Are there any other numbers which are both squares and cubes? Okay. So is there a way to describe such numbers in general? Okay, fine. See, the easy number. See, easy number you all know. That is 1. See, 1 can be written as 1 square, cube, 1 6, right? Which is divisible by both. 729 is another number which can be written as 3 raised to 6, 9 cube, 27 square, right? It is a cube number and a square number also. 4096. This is 4 raised to 6, 64 square and 16 cube. These are the numbers which are both square and cube. Okay. So generally they are asking for, is there a general way to describe this? So generally a number is both perfect square and cube if and only if is a perfect sixth power. Is a perfect sixth power. So how it comes now? See, ये आप शुरू से कर रहे हो है ना? Divisibility rule of 6. Mind that. Divisibility rule of 6. What was that? The number should be divisible by 2 and 3 both. Only then we'll say that it is divisible by 6 also, right? And similarly here, they both will be perfect square and cube if and only if it is a perfect sixth power. अगर वो sixth power में भी present किया जा रहा है, then we can present the number into power of 2 and power of, yeah. Moving to the next question, 11th. A digital locker has a alphanumeric. Alphanumeric means we have digits also we can use and we can use letters also. So letters के लिए we have choices. 26 letters are there in English alphabets, okay, and 10 digits we have in choice. So alphanumeric, okay. Now these days we use passwords alphanumerically. Passcode of length 5. Okay, the length should be 5. Some examples are given to you. How many such codes are possible? So see, we have choices of letters 26 and choices of digits is 10. And each character can be any of the 36 alphanumerical, right? The passcode, for the passcode, each character in the passcode can be any of these 36 alpha numerics, right? Also, each of the 5 positions. Why 5 positions? Because in question the passcode should be of length 5. It is asked, right? Each of the 5 positions has 36 options. 36 options. So total codes. The total codes will be 36 raised to 5. Fine. The answer will be a bit larger. So this will be the answer. Okay. We'll use 36 alphanumerics here. And for the 5 positions, each fifth, See, we have 5 positions, and every position is having 36 choices, right? That's why we are making them like this. So moving to the question number 12, that is the worldwide population of sheep is 10 raised to 9. That of goats is also about the same. What is the total population of the sheep and goats? I think this is the population of sheep. Population of sheep is given to you, that is 10 raised to power 9. And population of goat, it is also given, that is same, that is 10 raised to power 9. So total will be in both of them. When we are adding the same values, it will be twice of the value. The answer will be fifth. Answer will be fifth. Yep. Number 13. To calculate and write the answers in the scientific notation, first question is, if each person in the world has 30 pieces of clothing, find the total number of pieces of clothing. Okay, fine. So for this question, we must know that how many persons are there in the world. The world. Now we are now taking the approximate value. Okay. The first part, that world population, it is 8.2 billion. 8.2 billion. So for 30 pieces of clothing, right? 8.2 billion is 8.2 into 10 raised to power 9. Firstly, you must note this, okay? So pieces of clothes, that is 30 per person is given. So they are asking for total number of pieces of clothing, that will be, you will multiply 8.2 billion with 30. So let's simplify it firstly, right? We will multiply 8.2 into 30. For this, you can convert it into fraction and then multiply. Will be easy for you. Cancelling each other, and 82 into 3 is 246 into 10 raised to power 9. Now I have already told you how to convert this into scientific notation. The first term should be less than 10 and greater than 1. So it is 2.46 into 10 raised to power 11. Okay? This is the scientific notation of first part. Now moving to the second part of this question, that is, there are about 100 million bee colonies. Okay? 100 million bee colonies in the world, and find the number of honey bees if each colony has 50,000 bees. Okay, let's do it. So part 2, number of bee colonies, this is given to you. This is 100 million, right? 100 million means 1 into 10 raised to power, okay? And number of bee per colony is also given to you. This is 50,000, which can be written as 5 into 10 raised to 4. So they are asking for total honeybees, right? And the number of honeybees, it will be 5 into 10 raised to 4 into 1 into 10 raised to 8. So this is simple, 5 into 10 raised to 12. This was simple, right? We just calculate this. Moving to the third part. Third part is, if the human body has 38 trillion bacterial cells, find the bacterial population residing in all humans in the world. Again, all humans in the world. Fine. So world population again we are taking, right? World population. World population that we had already assumed that this is 8.2 billion. Okay, this 8.2 into 10 raised to 9. And in the question, uh, number of bacterial cells, this is 38 trillion. 38 trillion means 3.8 into 10 raised to 13. This is a scientific notation of trillion. Okay, so simple. Let's do it. The total bacterial residing in all humans in the world. This will be, you will multiply them. And it will leads you to this answer. You can try of your own. Okay. Last part. The time spent eating in a lifetime in seconds. Okay, fine. So according to studies, the average eating time per day, eating time per day is 1.5 hours, okay, according to studies. And if we convert into seconds, we need to convert this into seconds, then we need to multiply 1.5 with 3600, which is 5400. 5.4 into 10 raised to power 3. Okay, and we are taking average lifetime. Average lifetime of a person is, say it is 70 years. This is average time we are taking. And if we convert this 70 years into seconds, because we need same units, okay? So this will be 70 into 365 into 24 hours and then 60 minutes and 60 seconds. So this will be a bit larger value. And now what the total time spent? Total time spent will be, we will multiply these two values. Fine. We'll multiply the values. So we'll get around 8.7 into 10 raised to 14. This will be the answer. Okay. You can take assumption of this value for easy simplification of this answers. You can take it as 1.61 into 10 raised to 11. And then you multiply this with the term, you will get this answer. Okay. This is a bit calculative. Try of your own, you will get the answer. Okay. And lastly, you have last question, that is, what was the date around 1 billion seconds ago? Okay, fine. So this is a bit challenging question, but it is easy and it is calculative as well. So just be with me. So 1 billion seconds means, firstly, you must know this. 1 billion means 10 raised to power 9, right? That means what is the date if, before 10 raised to power 9 seconds? Now we are converting it into years. Let's do it. Converting it into years. That means 10 raised to power 9 will be firstly divided with 3600 seconds, 24 hours, 365 days, right? And it will approximately 31.10 years, approximate value, right? Which means 31 years, 8 months, 8 days. This is again, it is a prox value. Okay. 31.110 years means 31 years, 8 months and 8 days. Now subtract from today. Subtract it from today. Today is 22 March 2026. So firstly we are doing minus 31 years. 31 years minus किए तो we get 22nd March 1995. Okay. Obviously है ना 2026 में से -31 कर देंगे. Okay. Now minus 8 months. Minus 8 months. It will be 22 July 1995. Okay. This is March month. When we subtract 8 months, we get July here. Okay. Now minus 8 days. So 22 minus 8. It will be 14. 14 July 1990. Here I want to correct it that when we subtract the 8 months, the year will be 94, right? Right? Corrected. There will be 94. Okay. So here also it will be 14 July 1994. So this will be, the answer will be around 14 July 1994. So this is the approx answer. Okay. So about 10 raised to 9 seconds, the date will be 14 July 1994. Okay. I hope you understand the concepts. Yes, it is bit calculative. It's okay. You will get to know a lot of things after doing this chapter. Try hard, and if you have any doubt, you can comment. You can message also. Thank you so much.